So the next Higgs video is called Calorimeter Kinematic Variables Atlas 7 TEV Higgs Electron-Proton Scattering Beam. So this is talking about the beams. So September 29th is when I did the keyword searches for it, and today's October 4th, 2012. So the keyword searches are from HERA 1 to HERA 6, Higgs mass boson particle videos. So I guess it is continuing on. Sorry, I thought there was only 6 videos. I think there's more. I think there's about 8. Oh yeah, there is. Oh dear, I goofed up. There was some more research data that came up, and I broke it down into just individual videos. So I think there's another 1, 2, 3, 4, 5, 6 more. Wow, there's 12 videos about the HERA. So September 9th, 2012. Google to do calorimeter, Google. So quotes from Wiki, I wanted to find out what a calorimeter was. So a calorimeter, meaning heat, is an object used for calorimetry, or the process of measuring the heat of chemical reactions, or physical changes as well as heat capacity. So reconstructed kinematic variables, the keyword again was variables, so I googled it. Kinematics is the branch of classical mechanics to describe the motion of points, bodies, objects, and systems of bodies, groups of objects without consideration of the causes of motion. So the keywords from next was inclusive, deep, inelastic scattering variables, and the keyword was missing transverse momentum, and a PDF file came up, rx.org, from the performance of missing transverse momentum reconstruction in proton-proton collisions at 7 TeV with Atlas. So again, Atlas collaboration comes up yet again, so obviously we need to look at that data for the Higgs field. It was submitted August 2011, published in December. The measurement of missing transverse momentum in the Atlas detector, described in this paper, makes use of the full event reconstruction and a collaboration based on reconstructed physics objects. The performance of the missing transverse momentum reconstruction is evaluated using data collected in PP collisions at a center of mass energy of 7 TeV in 2010. The minimum bias events with jets of hadrons are used from data samples corresponding to an integrated luminosity of about 0.3 inverse NB and 600 inverse NB, together with events containing a Z boson decaying to 2 leptons, electrons or muons, or a W boson decaying to a lepton, electron or muon, and a neutrino from a data sample corresponding to an integrated luminosity of about 36 inverse PV. An estimate of the systematic uncertainty on the missing transverse momentum scale is presented. And that's from High Energy Physics, and there's the reference number for it, okay? And there's the website that you can find it on. September 19th. Okay, so EP scattering events. So I'm going to Google that. I always write the word Google beside anything. I'm not sure what it means. So the keyword is deep scattering, keeps coming up. Keywords EP elastic scattering on CLAS, CLAS, and electron-proton scattering. So those are the ones I'm going to be looking at. This came up, beam energy measurement with EP elastic scattering on CLAS, and it's from www.jlab.org. Transverse energy of tracks in a cone around the jet. Keywords transverse energy of the photons, fragmentation function, jet particle physics. There's a diagram. The top quark and anti-tap quark pair decaying into jets. Visible as collimated collections of particle tracks and other fermions in the CDF detector at Tevatron. So this is quotes and data from Wiki. A jet is a narrow cone of hadrons and other particles produced by the hadronization of a quark or gluon in a particle physics or heavy ion experiment. Because of QCD confinement, particles carrying a colored charge such as quarks cannot exist in free form. Therefore, they fragment into hadrons before they can be directly detected, becoming jets. These jets must be measured in a particle detector and studied in order to determine the properties of the original quark. In relativistic heavy ion physics, jets are important because the originating hard scattering is a natural probe for the QCD matter created in the collision and indicate its phase. When the QCD matter undergoes a phase crossover into quark-gluon plasma, the energy loss in the medium grows significantly, effectively quenching the outgoing jet. Example of the jet analysis techniques are jet reconstruction, a KT algorithm, cone algorithm, jet correlation, flavor tagging, EB tagging, which I cover in a later video, just so you know. Example of jet fragmentation models are Lundstrom model. So the decay products with momentum in the same direction as the momentum of the top. That's from www.quantumdiaries.org. And here is a diagram. Low top PT, high top PT, and it's BW boost, and it changes it into a more circular signal. If, for example, this is a quote from Wiki. Actually, it's not from Wiki. Sorry, it's from Quantum Diaries. If, for example, we're able to produce some kind of new physics interaction with a really heavy mediator, such as a Z beyond the standard model heavy equivalent of the Z boson. So you might want to cross-reference this with the other video where I give you some ideas on creating 5 other standard model particles, brand new particles, with your tests. So the mass of which would have to be converted into energy somewhere. Generally, we reconstruct the energy and mass of a hadronically decaying top by combining the 3 jets it decays into. But what if the top was so boosted that the 3 jets merged to a point where you couldn't distinguish them and it just looked like one big jet? This makes detecting it even more difficult, and a fully hadronic T-bar event is almost impossible to see. So that's from quantumdiaries.org. So September 19th, it was when I was working on the data. Again, today's October 4th. I probably already said that. So this is the keywords from the data, and this is the formula of ideas. So you're going to do deep scattering, keeps coming up. Add your EP elastic scattering plus CLAS plus electron-proton scattering plus beam plus energy plus measurement plus transverse plus energy plus photons plus fragmentation plus function plus jet plus particle plus physics. Top quark plus anti-top quark plus decaying plus jets plus visible plus particle tracks plus other fermions plus CDF detector plus tevatron. Jet equals narrow cone plus hadrons plus other particles plus hadronization plus quark plus gluon plus particle physics. I'm going to stop saying plus because it gets annoying. Heavy ion experiment QCD confinement particles color charge quarks freeform. Relativistic heavy ion physics jets hard scattering, and I don't know how to spell. QCD matter created collision phase crossover quark gluon plasma energy loss grows outgoing jet. My thoughts: the quark gluon plasma mixed with liquid argon gas, neutrino formula for the beam. That's in the WOW videos. A quark gluon plasma. This is a quote. A quark gluon plasma QGP or quark soup is a possible phase of quantum chromodynamics QCD, which exists at extremely high temperatures and or density. This phase consists of asymptotically free quarks and gluons, which are several of the basic building blocks of matter. Experiments at CERN Super-Proton Synchrotron SPS first tried to create the QGP in the 1980s and 90s, and the result led to CERN to announce indirect evidence for a new state of matter in 2000. Oh, I didn't hear about that one. I wasn't doing this in 2000, so I just started doing this in 2012. That's why, 12 years ago. Current experiments 2011 at the Brookhaven National Laboratory's Relativistic Heavy Ion Collider, RHIC, on Long Island, New York, USA, and CERN's recent LHC collider near Geneva, Switzerland, are continuing this effort by smashing relativistically accelerated gold ions at LHC lead ions into each other. Although the results have yet to be independently verified as of February 2010, so they were still working on this 2 years ago. Cool. Scientists at Brookhaven RHIC have tentatively claimed to have created a quark gluon plasma with an approximate temperature of 4 trillion degrees Celsius. Wow, so that's hot. As already mentioned, 3 new experiments running on CERN's Large Hadron Collider, LHC, on the spectrometers ALICE, ATLAS, and CMS will continue studying properties of QGP. Starting in November 2010, CERN temporarily ceased colliding protons and began colliding lead ions for the ALICE experiment. They were looking to create a QGP and were expected to stop December 6, colliding protons again in January. A new record-breaking temperature was set by the CERN group on August 2012 in the range of 5.5 trillion degrees Celsius as claimed in their Nature PR. The strength of the color force means that unlike the gas-like plasma, quark-gluon plasma behaves as a near-ideal Fermi liquid, which, although research on flow characteristics is ongoing. So I googled Fermi liquid to see what that is. And Wiki quote says, He3 is an isotope of helium with 2 protons and 1 neutron and 2 electrons per atom. Because there is an odd number of fermions inside the atom itself is also a fermion. The electrons in a normal non-superconducting metal also form a Fermi liquid, as do the nucleons, protons, and neutrons in an atomic nucleus. Strontium nuclei displays some key properties of Fermi liquids despite being a strongly correlated material and is compared with high-temperature superconductors like cuprates. 24th September formula from the data. You have your calorimeter plus measure plus heat plus chemical reaction plus heat capacity, reconstructed kinematic variables, motion objects, motion, deep, inelastic, scattering, transverse, momentum, reconstruction, proton-proton collisions, 7 TeV, Atlas detector, PP collisions, center of mass energy. Next is jets, hadrons, luminosity, Z boson, decaying, 2 leptons, electrons, muons, W boson, decaying, lepton, electrons, muon, neutrino, beam energy measurement, electron-proton electric scattering, and colliding. So your keywords to remember is He3 is an isotope of helium with 2 protons, 1 neutron, and 2 electrons per atom. I'm going to research more keywords in the next video. Okay, so basically the next few videos are researching the keywords and then grabbing formulas so that I have keywords to compare later on. Okay, thanks for watching my research, and I'll see you again soon.